and good morning everybody. My name is Qvintus and I'm here to start the first session of Renewal by Rethinking as an introductory presentation to the five other presentations in the session. So, in general, the trend in paper production and consumption has been decreasing for last decades, and the forecast is that the trend is continuing. So, some renewal is needed. The vision for future is written in the strategic research agenda of Forest Technology Platform. The objective is to double the value of the forest cluster products and services by 2030, and half of this value would come from new products. Even if we think about using wood as raw material, we don't think it anymore as a wood only. We think it as a class of bio-based materials or different grades of advanced nanomaterials. And by use of lean processes and new production technologies, we aim to radical big savings in use of resources like raw materials, energy and water. We also aim to create totally new value-added products for the industry. The challenges are in maintaining the competitiveness of existing processes and industry, and in taking the forest sector beyond pulp and paper production. The Association of Forest Industry in Europe, the CEPI, sees following technological challenges: resource and energy efficiency, conversion efficiency, product efficiency, and development of new products. At VTT, we have specially focused to resource efficiency, development of resource efficiency, and to development and creation of totally new products for the industry. When we look at the schematic view of pulp and paper making process, we can see that it is a long and complicated process consisting of many different stages. And when we aim to renew the process, the natural starting point is in the beginning of the process, in the modification of or tailoring of the raw materials, in development of short circulation, in development of forming, pressing, drying stages. And at VTT, at the moment, we have specially focused on the development of the forming process. We have adapted technologies from different areas, like from producing of nonwovens. We have adapted foam technology to the production of paper and board products. Janne Poranen will go more in detail in his presentation in the use of foam technology in paper and board making. Foam technologies can also be used in coating or surface treatment of fiber-based products, especially when we want to transfer small amounts of organic materials in water suspensions to fiber-based webs, and we want to avoid transferring of huge amounts of water. We can use foam application. Karita Kinnunen's presentation will focus to this topic in the session. We also want to build the foam applicator unit to our innovative surface treatment and coating line, Sutco. This is specially designed for utilization of new bio-based materials in surface treatment of fiber-based matrices for barrier and coating development. One innovative example of the use of Sutco coating line is production of nanocellulose film by coating it as a water suspension to a supporting film and then by film forming by drying. By this technique, we can produce different thicknesses of nanocellulose films. In general, these films are very strong, they are very smooth without any biomarkings, and the exploitation potential in future is huge. It can be used in development of barrier films as a part of composite structures or as a substrate for printed electronics or flexible displays, OLEDs. Vesa Kunnari will go more in detail to the technique used in production of nanocellulose films by Sutco line. Our aim at VTT is to combine expertises in tailoring of raw materials, in using of new techniques in web forming, and to bring new properties by innovative surface treatment technologies to the new kinds of end products. Besides our surface treatment line, we have also adopted new technologies from other industrial areas. Atomic layer deposition was originally used in production of electronic components. We have used atomic layer deposition for development of nanoscale inorganic barrier layers to fiber-based matrices to form new kinds of bio-based barrier materials to be used instead of synthetic or metallic barriers in, for instance, packaging applications. Jenni Sievänen will give an overview of existing ALD techniques at VTT today. We have also used traditional printing methods to produce totally new kinds of products. We have used printing methods as manufacturing techniques for different functional products. One example of functional products printed on fiber-based matrix are applications of bioactive paper. They can be, for instance, simple applications of diagnostics or personal health care, or just for decorative purposes. And Tomi Erho's presentation will open up this topic. At VTT, we have been doing a lot in material research for development of advanced materials, in development of process technologies, and also product development. And our aim is to combine advanced materials to specific process technologies so that we can get the properties needed for special products with added value for the future. Our infrastructures cover almost everything, starting from the tailoring of fiber-based raw materials, to forming of the web, pressing, drying, coating, surface treating, printing, even trial production of demonstrator packaging. So, thank you for listening, and if you want some additional information of these topics, you can contact me or my colleague Erkki Hellén or the present other speakers in the session later on.